Hello, my name's Val Freeman, and I'm the Laboratory Safety Program Manager for Environmental Health and Safety. Today, we're going to be talking about laboratory safety. Two things that OSHA Laboratory Safety Standard requires to be done is general laboratory training and lab-specific training. This module covers general training for laboratory safety. Lab-specific training should be done by each lab's principal investigator. That way, each personnel that works in the lab is given all of the hazards that are specific to that lab before they start their work. Make sure to document all training. OSHA always says, if it's not documented, it never happened. So make sure every training you are documenting with signatures and dates. Training is necessary for all of our personnel so that they know what kind of hazards they may be exposed to, what kind of procedures they may be working with, to avoid any sort of accidents in their laboratory that may happen. They should know how to handle, store, and dispose of any sort of hazards that may be present and that they may be working with. Some of the regulations that may affect you in the laboratory include the OSHA Lab Standard for any laboratory that's going to have hazardous chemicals. The Bloodborne Pathogen Standard, if that lab happens to have any infectious agents that are a bloodborne pathogen, or they handle human tissues, human cell lines, human blood, or non-human primate blood or tissues. The respiratory protection regulations may apply anytime that there may be some risk of inhaling toxic fumes, vapors, gases, or dust, and it requires the use of a respirator. The Hazard Communication Standard really applies to all industry. Every employer should be communicating what hazards their employees may be exposed to during their work. The Personal Protective Equipment Standard obviously applies to any work that involves any requirement for wearing personal protective equipment to reduce the risk of exposure. For the Laboratory Safety Standard, which is 29 CFR 1910-1450, this one again applies to all laboratories that's going to have a hazardous chemical present. It requires a written program called the Chemical Hygiene Plan, and it also requires training, not only at the start of work, but also annually it needs to be done again. For the Bloodborne Pathogen Standard, this applies again to labs that have infectious agents that happen to be bloodborne pathogens, or they do work with human cell lines, tissue, blood, or work with non-human primate cell lines or blood. It requires a written program called the Exposure Control Plan, and this again needs to be requires regular training annually, as well as before any job is started. This particular training has to be done in person, not online, so that you guys can always interrupt and ask questions at any time. The Respiratory Protection Standard applies to any laboratory that's going to have the possible exposure to harmful dust, fumes, mist, gas, or vapors, and requires the use of a respirator. It also requires a written program called the Respiratory Protection Program, and it requires regular training. Again, the Hazard Communication Standard applies to pretty much all industry and to require those employers to inform their employees of any sort of hazard that they may be exposed to, especially those hazardous chemicals. It does have a written program that's required, the Hazard Communication Program, and it requires, again, regular training annually, as well as before the job starts. For the Laboratory Standard written program, you have the Chemical Hygiene Plan. This is not the same as the Laboratory Safety Manual. The Laboratory Safety Manual is very general. It's also very long. Our laboratory safety manual for OSU is over 60 pages long, and it covers all the general safety for any laboratory on campus. The chemical hygiene plan is made specifically for the lab that you will be working in. It is created by the PI, and it's going to inform you of all the hazards that you may be exposed to during your work in that laboratory. And it also tells you what PPE requirements you have for any of your procedures or even entering that laboratory. So this program is going to state all the policies and procedures and responsibilities that protect those workers from being exposed to those hazardous chemicals. And it should address every aspect of handling those chemicals. That goes for the buying, storing, handling, as well as disposal. So the entire life of that chemical while it's in the laboratory. It does need to have documented training for the chemical hygiene plan as well. Make sure you document it, like I said before. If you need the template for a chemical hygiene plan, please contact us at EHS and we can help you with that. So some of the hazard communication that we are covering, which the laboratory standard covers for laboratories, it should include the chemical inventory list, which we'll go over a little bit more. It should include the safety data sheets, SDSs, for those locations. There should be placarding, which we'll cover more in detail, labeling, documented training, all together with the written hazard communication program, which for the laboratory standard, which would be the chemical hygiene plan. Chemical inventory lists are required for every laboratory location. The PI should be, by obligation, updating their chemical inventory lists on a regular basis. They should be doing this at least once every 6 months or any time new chemicals are added to the inventory. For placarding, this should be posted outside every door here on campus. It should have the required PPE that is needed to enter that space. It should have the GHS, or the Global Harmonized System, pictograms, those red diamonds with the black and white picture inside, to let you know what hazards you may be exposed to when you enter that space. Should also have the NFPA diamond, the diamond with the blue, red, yellow, and white squares. There will be a number from 1 to 4 in those boxes to indicate the different hazards and how serious those hazards may be. This really is for first responders to take a quick glance to see what kind of hazards they may be dealing with and when they're entering during an emergency. OSU also requires that emergency information is posted outside the doorways to let us know who's in charge of the space, how do we get a hold of them, who's the department head, and what kind of special hazards may be in that space. All of this placarding should be displayed and unobstructed. So if you have a door with this signage on the outside, you should never be propping that door open for long periods of time, because when people enter those spaces, they will not be able to see what hazards they may be exposed to or what PPE is required when they enter. All of this placarding requirements are listed in the Lab Safety Manual for further reminders. EHS can assist with laboratory entrance signage if you fill out our form on our website. Our department can actually make the forms, laminate them, and deliver them to the site that is requested. Some other laboratory placarding that you may see on the outside of the doorways are for radiation, laser safety, as well as biohazardous. Unfortunately, these are not covered by EHS, so for more information on this placarding, you should contact the Radiation Safety Office or IBC, the Institutional Biosafety Committee. For chemical storage signage, make sure to clearly identify any cabinet that you cannot see into clearly that there are some sort of chemicals inside. That signage needs to have letters that are at least an inch tall to let people know that there are chemicals inside of it. You can use individual cabinets for each class of chemical, or you can use secondary containment, such as totes, to separate your different classes of chemicals in those cabinets. For labeling, make sure to not deface or remove manufacturer's labels. If they become damaged, make sure to replace those labels with all the pertinent information. All labels need to be in English. And the main two things that we are required by OSHA to have on those labels are the name of the chemical, which cannot be abbreviated, and the hazard. You can either use the GHS pictograms for your hazard, or you can write them out. Just write the word flammable or corrosive on the label. For newly synthesized chemicals, this would be the exception to the rule. If you happen to have a newly synthesized chemical, it may not have a chemical name, you can draw the structure of that chemical on the label. But it still requires that there be a hazard indicated on the label as well. That may have to be an estimation from looking at the individual chemicals used to make that chemical. Some other labels that are required include a label for a peroxide-forming chemical. Anytime you have a chemical that is a peroxide-forming chemical, it has an additional hazard that needs to be communicated to anybody who's handling that chemical. These chemicals form peroxide crystals with being exposed to oxygen and to light, and those crystals can become very reactive to either heat or shock and can explode. So these need to have additional labeling on them. We recommend that that label include when that chemical was received, when it was opened, when it expires, and any test dates that chemical was tested for peroxides. So here we have a group of 5 different chemicals that have a label on them, but in each of these they contain a beverage instead of what is labeled on the bottle. Very often on this campus we see people reusing some of their containers for other chemicals. Now, I'm not against reuse of containers. We want to have a green campus, so I am fully encourage people to reuse. But make sure those containers are compatible with your chemical and that you are defacing or removing the old label before you put in another chemical. Many times we have people that leave the old labels on and then no one understands what is actually in them or can use the wrong chemical when going through a new procedure. You cannot tell what a chemical is just by looking at it. So like I said before, all of these happen to have been labeled with some sort of chemical that you definitely wouldn't want to drink, but they happen to all be beverages. Here's an example of one of those peroxide-forming chemical labels that I mentioned before. Again, these labels have the date received, the date open, and any test dates that they were tested for peroxides previously. Here is a guide if you're wanting to look for companies that create labels and signage for laboratories. This is on our website at ehs@okstate.edu. More on chemical storage. Again, storage of chemicals, they should be separated by different chemical classes. For instance, you wouldn't want to put your flammables with your oxidizers. You wouldn't want to put your acids with your bases, etc. Clearly identify those storage locations with proper signage. Make sure you're not storing your chemicals on the floor And if I know that space is a commodity here on campus, and if you have to store on the floor, make sure you have some sort of proper secondary containment for those chemicals so if they get knocked over, you're not going to cause additional hazards with slips, trips, and falls. Containers also must be appropriately labeled before put into storage. So after a procedure, make sure everything is labeled before putting them away. Here's an example of a chemical storage system that we have in our laboratory safety manual to help guide you on deciding on how you want to separate your different classes of chemicals. This is just an example though. Every lab is different in what chemicals they have and may have different storage systems set up. When it comes to refrigerated chemical storage, a very common deficiency we see here on campus is storage of flammables in a commercial or a household refrigerator. They say that there are anywhere from 11 to 14 different spark points in a commercial household refrigerator. Think about every time you open the door and the light comes on, or the compressor turns on or off, or the thermostat clicks. All of these could cause a spark inside that refrigerator. If you're storing flammables, I'm sure you can put those lids on tight, but not tight enough for fumes not to escape over time and build up in that refrigerator that is built to seal properly every time you close the door. If a spark starts, you could ignite an explosion. So make sure, if you are storing flammables in a refrigerator, to store it in a laboratory grade refrigerator that is designed for flammable storage. Also make sure that all chemical refrigerators have a no food or drink sign on the outside. For compressed gas storage, make sure you're storing all of your gas cylinders upright. Keep them away from any heat or open flames. Do not store them in walk-ins, as there's no ventilation in those walk-ins. Segregate those gases just like you would segregate your chemicals. So don't be storing any of your oxygen tanks next to a flammable gas. In fact, those need to be 20 feet away or separated by a firewall. Secure your cylinders to a permanent structure, not something like a table that can move. Those cylinders are very heavy, and if they tip over, they're just going to pull that furniture with it. So make sure you're securing those cylinders to a permanent structure. Double chaining is recommended, but if you're only using a single strap, make sure it is between the waist and the shoulder of the cylinder. We also recommend that it is a chain and not a nylon strap, especially for those flammable gases. If there is a fire, those nylon straps will melt very quickly, and then those cylinders can tip over and cause more damage. Cylinder racks are also strongly recommended. Keep your valve caps on your cylinders anytime they are in storage or not being used. Remove the regulators when they're not in use. Make sure all the cylinder labels are faced out so everybody can see them. And make sure to put some sort of signage to let people know if it's full, in use, or empty. If you suspect any of your cylinders are leaking, remove that cylinder as soon as possible and call your supplier. For emergencies in the laboratory, there will be emergencies occasionally in our labs. Most of them are small and can be handled. If it's something large, for instance, we do live in Oklahoma, we may have a tornado evacuation. Make sure to stabilize all your reactions that are in progress. Close any of your fume hood sashes and close the lab door on the way out. That's going to compartmentalize any fires and slow the spread to allow more time for people to get out in case of a fire. Notify your PI because obviously they're going to want to know that there was an evacuation of their laboratory and what that reason was. Also notify 911 and EHS. For emergency posting, make sure to have emergency numbers posted in a well-known area for all of your personnel. These days, a lot of phones are not in our laboratories anymore because most people are carrying their phones in their back pocket. So you may want to think about where you want to post those phone numbers. Maybe at your exit that gets used the most, entrances and exits, and let people know, all of your personnel, where those numbers are posted. Here's some of the numbers that EHS keeps for the campus emergency numbers as well as off-campus emergency numbers. And here's that emergency contact information I mentioned that is also required to be on the outside of all of our laboratory entrances. Again, it lets us know who's in charge of the space, how to get a hold of them, who's the department head, and what special hazards are in that location. These should be posted outside the doors, and you should send a copy of this to EHS as well, so that in case of an emergency and dispatch happens to need more information, we will be able to give them the information of who is in charge of that space. For laboratory safety equipment, you may see eye washes, safety showers, drench hoses, or fire extinguishers in many of our labs. Make sure that this equipment is unobstructed and well marked with signage. Each employee that works in that space should know the location of all of the safety equipment. All of the equipment is checked on an annual basis by EHS. So the eye washes, drench hoses, and showers are tested by EHS every year, and the fire extinguishers are tested every month. For the eye washes and drench hoses, though, it is also required by ANSI and OSHA for those to be tested once a week. There's two reasons for this. One, testing them weekly will make sure that they are still in operation. If they're not, you can quickly have FM come in and make repairs. Also, if EHS is the only one testing the equipment, that water can sit in those pipes and collect rust, sediment, and other growth in those pipes. If an emergency actually happens and someone needs the eye wash, for instance, they don't want to be flushing rust and sediment into their eyes in addition to the injury they may have already had. Chemical fumids are probably the most common safety equipment that's used in the laboratories. So this is the primary engineering control of choice in the lab, and it's constantly pulling air away from the user through the fume hood and out the exhaust to keep users safe from hazardous fumes or dust or vapors that they could inhale. There should be a sticker on the outside of the hood letting you know that it is in good operation. If there's a sticker on the hood that says out of service, do not use this hood. It is not going to protect the user from any of the vapors and fumes that they may inhale. Make sure to work 6 inches inside of the hood. Do not clutter up the hood space because you may block the baffles that are going to help the airflow as pulling all of those vapors away from the user. If you do need to put any large items into the chemical fume hood, some piece of equipment, make sure to elevate it a couple of inches so that air is being pulled underneath that equipment and away from the user. Secondary containment, like I said, can be used to store your chemicals in segregated areas, such as in the picture on the top right. But it is also required for transferring chemicals from one location to another. You can use things like totes, buckets, or carts with lips on every side so that it can contain any spilled liquid during that transport. Acutely hazardous chemicals may be stored in a fume hood as secondary containment. For instance, hydrofluoric acid is one of those acutely hazardous chemicals that are allowed to be stored in a fume hood as secondary containment. For electrical safety in the laboratory, make sure that the wiring is going to be adequate to carry the desired current. So make sure you're not daisy chaining one power strip into another power strip in the laboratory. Those power strips are not made to carry that much amperage and can over time heat up, cause melting and sparking and a fire hazard. Also make sure that all of your cords are in good condition, and if there is any sort of fraying or exposed wires, that you take care of that. A lot of the buildings on this campus were built before some of the codes had been brought up, and that require things like a GFCI or a ground fault circuit interrupter on the outlets that are near a water source. Every outlet that is within 6 feet of a water source is required to have a GFCI. In many of these cases, in these older buildings, there still are not GFCIs near the water sources. So make sure you're paying close attention to what kind of procedures and what equipment you are using near those water sources. Do not obstruct any of the circuit breaker boxes in your laboratory with furniture or equipment. Also avoid using extension cords. These are only for temporary use or for hand tools when you're in the laboratories. If you're needing to use an extension cord for a piece of equipment, then you really need to talk to your department to have some sort of permanent solution put in place or a new outlet. Also make sure that your equipment still has the proper grounding before you use it. For housekeeping, a clean lab is a safe lab. Make sure that you're not blocking access in any of the walkways in your laboratory. Make sure those circuit breaker boxes are clear of any obstructions. Clean your work areas on a regular basis and put your trash away when you're done. Any chemicals that you are using during the day, put back after you're done with proper labeling and lids and caps in place. Dispose of any waste in the proper receptacles in the satellite accumulation areas. And make sure not to store your chemicals in the floor or in the fume hoods. Use sharps containers to get rid of any sort of sharps, and broken glass in a sturdy cardboard box specifically for broken glass. Store any items or equipment on the bench tops, I would say at least 6 inches away from the edges. This will prevent people from hitting or knocking over equipment as they walk down the aisles. For animal laboratories, there may be additional potential hazards with this research. Make sure that all members of the laboratory are trained on these hazards and what required PPE may be needed for working in that laboratory. There may also be specific standard operating procedures that change the way you enter and exit those areas, such as how long lights have to be on or off, or who is actually allowed in that area during those procedures. For a job hazard analysis, all of the research scientists should be doing these job hazard analysis for any procedures that they are doing in their lab. This is just a technique to identify all the different hazards that are related to the tasks that they are requiring their workers to do. So to do a job hazard analysis, make sure to involve your employees. Break the job up into shorter steps so that you can identify each hazard in each step. And then you can try to eliminate or reduce that hazard with some kind of mitigation. Here's an example of a job hazard analysis form that is included in the laboratory safety manual. Again, it just breaks up that procedure into shorter steps to identify those hazards and then come up with some ways or controls that are going to reduce the exposure to that hazard. The 4 routes of exposure are inhalation, ingestion, skin absorption, and injection. Eye hazards are pretty easy to spot. Any sort of splashing of a chemical is going to be an eye hazard. And 90% of eye injuries happen because people aren't wearing their PPE. Handling any sort of hazard with your hands, you should be wearing some sort of hand protection or gloves. This particular gentleman decided that it was okay not to wear a pair of gloves because he was dealing with bases rather than an acid. But bases are can be just as corrosive as an acid. This particular person had a splash to the face. The skin on their face will heal eventually, but eyes do not heal nearly as well or as fast. But if you see around the eyes, there's no injury. This particular person was wearing a pair of safety glasses when they received this chemical burn. So they went away with some burns to the face that will heal, but their eyes were protected. This particular person decided that it was okay to wear flip-flops into a chemistry lab. After an acid spill, they unfortunately suffered an injury to their feet. Closed-toed shoes are a requirement in your laboratories as well as long pants. This is part of the PPE that is required for the laboratories. There's an additional video for glassware handling that you can copy and watch at a later point. For glassware handling, is this what your lab looks like? Glassware storage can become a hazard in your laboratories. We don't want anyone receiving a cut or tripping and falling because of the glassware that may be on the floors. Make sure to rinse all of your glassware after you're done working with them rinse from any residues or chemicals. Decontaminate them if you've done work with biologic. Make sure that no sharps are going into those glassware bins, and do not overload these glassware bins. All that broken glass, like I say, can go in a sturdy cardboard box. Once they're full, you can tape those up properly and dispose of them in the dumpster. Make sure to replace any cracked or chipped glassware as well. That is a very common injury, is cuts from handling glassware with chips and cracks. If you happen to have glass that is in good condition but you no longer need it, you can call EHS for disposal, and we can put it with our reuse glass and let other laboratories on campus have access to that glass. Another common injury that we've seen on campus occurs when scientists are placing pipettes into rubber stoppers. Those pasture pipettes are pretty thin glass and can very easily break and cause an injury to the hands. Anytime you're doing this procedure, before you start, lube the pipette as well as the rubber stopper before you do it, and also put on some hand protection, some thicker gloves or some towels to hold those in place so that if it does break, you don't end up injuring your hands. Vacuum flasks are another thing that can easily break when you're trying to put a tube onto the end of the vacuum flask. This was an injury of an investigator who had one of those pasture pipettes break, and they accidentally inserted that pipette right into their hand. So it really is important to put some hand protection before you start this procedure. If you have to work with a compound with an unknown toxicity, you need to set up a designated work area and isolate those items before you start working. A fume hood is a really good place to do this. Make sure people know what you're doing before you get started, and use appropriate PPE and wash your hands often. For pregnancy, any woman who ends up pregnant while they're working in a laboratory should talk to their general physician, let them know what kind of hazards they're exposed to during their work, and their physician can make recommendations that they can bring to work to come up with alternative work assignments or any sort of mitigation. Before leaving your laboratory, make sure that all of your overnight operations are clearly set up. Any sort of water lines are adequately clamped off. We don't want to cause a flood in our laboratories while we're gone. Make sure any heat sources are turned off. Any fume hood sashes are closed. And make sure all of your chemicals have been labeled properly and put away when you're done. All of us are trying to build a good safety culture on this campus. To do that, we want to establish lines of authority. Make sure we know who is responsible for all of the procedures in a certain location. We want to advocate for safety and safety education. We want to establish a good, effective safety program, not just as a campus, but even in our departments and in our laboratories, have an effective safety program. We want to make sure that faculty, staff, and students are trained properly before they do any procedures. We also want to implement hazard analysis procedures for any kind of procedure that we're going to be doing. We want to integrate safety culture in all parts of our curricula. We also want to make sure there's safety training during all phases of our research. From those students that are coming in just for a small project, all the way to our lab managers that are in charge of everything that goes on in that space. We always want to adopt some sort of personal credo as a safety ethic, making sure we put safety first. I know research is important and that we need to get it done, but we really want to think about, are we going to be safe before we start this procedure? We also want to utilize incident reporting systems. For instance, our campus has an employee injury report that you can use anytime that an injury occurs. We also want to have proper internal accident analysis procedures in case any of those incidents happen. And you want to share those lessons learned so that people aren't repeating the same mistakes. In all of this, you should utilize the guidance and the expertise of EHS. We are here not just for the faculty and staff, but the students as well. If the students aren't here, none of us have a job here on campus. So we want to make sure that all of us are going to be happy and healthy at the end of the day. Here is a current contact list for all of the people that are involved in environmental health and safety, as well as radiation safety and IBC. A few questions about lab safety. Can the safety data sheets be kept on a computer? Yes, they can be kept on a computer. In fact, the online chemical inventory system allows for the storage of safety data sheets with every chemical. But does everyone have access to it when they're working in the lab? Is there a computer available? Is the Wi-Fi working? You have to think about these questions in case of an emergency and they really need to get to a safety data sheet quickly. So we also recommend having hard copies of those SDSs in a central location in every lab. Who do you contact about a defective compressed gas cylinder? For this, we will recommend contacting the supplier. Maybe Airgas, maybe Stillwater Steel. Those are the people that are going to be able to quickly help get rid of or remove a defective compressed gas cylinder. What do you do with broken glass? Once again, broken glass can be put in a sturdy cardboard box. When it's full, tape it up securely and it can be put into the dumpster. Can students work in a laboratory by themselves? I would not recommend any student working alone in a laboratory. Anytime anyone is working in the laboratory, people should know what they're doing, when they're going to be there, and when they're going to be done. Someone should also be checking to make sure that everything is going correctly and safely. What do you do if a fume hood alarm is going off? For this particular occurrence, you can contact EHS and we can come and test that particular chemical fume hood to see if it is still in good operation. If you have any questions about laboratory safety or anything safety related, please feel free to contact us at EHS. You can call us by phone at 744-7241, or you can email us at ehs@okstate.edu. We also have a lot of information available on our website at ehs.okstate.edu. So if you have any questions, please contact us at any time.